we are going to discuss about the measurement. In particular, why do we need measurement in our study of physics? So you see, physics is broadly the study of nature. Okay, study of nature. So in our quest to understand how does the nature behave, so we have to measure several quantities. For example, if we want that what will be the what is the temperature of certain body, then we need to actually measure it. So that's why we need to measure several quantities and then compare the values that we get with other values that are in our hands that we already know. So that's why we need measurement. So now as we move along in our discussion of physics, we will see that one of the purposes of physics is to design and conduct various experiments which actually establish the units of these physical quantities. So what are the physical quantities? So which I have just mentioned that what do we measure? We actually measure various physical quantities. What can be the physical quantities? For example, temperature is a physical quantity. Speed of a moving object is a physical quantity. Mass of certain body is a physical quantity. So one of the purposes of physics is to design and conduct various experiments through which we try to establish the units of these physical quantities. Now the question comes, what do we mean by units? So units are actually names given to the measures of any physical quantity. So for example, let us say the physical quantity in question here is time. So when we say that the time is let us say 1 second. So that means this second is the unit of time in this case. Okay, where time is a physical quantity and second is the unit of time. We will see that there can be several units of time depending on the conditions and the preferences that we make, but it is one of the examples. Second is one of the examples of the units of time. So when we say certain thing is, let us say 1 second or 5 seconds, the time taken in order to reach from point A to point B, let us say the time taken is 5 seconds. So what do we mean? How do we know that this time taken is 5 seconds? Time taken is 5 seconds. What does this number 5 signify? So this 5, remember we said that we make measurements and then we compare it. We compare our measurements with some things. So those some things are called standards. So over many years, scientists have established various standards for various physical quantities. So in this case, when we say the time taken by an object to reach from point A to point B is 5 seconds, then we mean that the time taken is 5 times the unit, the standard in which we measure the time. The standard here being 1 second. Okay. Similarly, the standard for let us say distance can be 1 meter. So this meter, we will see that it is a unit for length. One more thing, a standard must be sensible and practical. We cannot say that whatever we choose to declare as the standard of certain physical quantity, it must make sense and it must be practical also. So now, as we move along in our study of physics, we will see that there are several physical quantities in physics. So much so that it often becomes very much difficult to organize them. So fortunately, not all of them are independent. So they are dependent on certain other physical quantities which we call as base quantities. For example, one of the base quantities is length with the unit, let us say, meter. Another base quantity is time with the unit, let us say, second. So speed, for example, is another physical quantity, but it is dependent on these two other physical quantities, length and time. So speed can be defined as length over time. So the unit being meter per second, because the unit of length is meter and the unit of time is second. That's why the unit of speed becomes meter per second, because we have defined speed to be the distance traveled in a given amount of time. So this base, so the standards corresponding to these base units become base standards. Okay, so base standard must be defined in a way that they are accessible and invariable. These are the two conditions that any base standard. What are the base standards? First, the standards which we have defined for the base quantities. What are the base quantities? That we will see in a moment. So what do we mean by accessible and invariable? Okay, so here invariable means that if I am declaring that a certain span in space, I am defining it as 1 meter, that is the standard of length, let us say. Then this same length, and I am sitting in India, then the same span should be called 1 meter in any other country or any other geography at any other time. Okay, so it should not be like I am defining this much length to be 1 meter in India, and some other scientist sitting in Australia says that no, this much length is 1 meter. No, it must be, the standard must not vary. Okay. And the second condition for base standards is it should be accessible. So whatever is the accepted standard, accepted base standard, for example, in our case, we are proceeding with the example of length. So this should be this span of space, which we are calling as 1 meter, should be accessible by any other scientist sitting in any other place. Okay, that is accessible, so that he or she can actually make comparison, that if the measurement is some distance, then he or she should be able to compare his or her measurement with the standard. So that's why It should be accessible as well as invariable. Now, there is a general body of international scientists who are actually working in the area of metrology. Metrology is a science where we actually make measurements. So those scientists, they meet at regular intervals of time, and that meeting is called General Conference on Weights and Measures. So they have accepted that there are 7 base quantities and their standards, and these base quantities are called SI units. So what are those base quantities? So for most of the part of mechanics, that is the first thing that we are going to study in physics. So these are, so most widely used are length, whose SI unit is meter, mass, whose SI unit is kilograms, and time, the SI unit for which is second. These are 3 of the most widely used base units, base quantities in our study of mechanics. But as we progress along, we come across other base quantities, or the SI units are defined for them. For example, temperature is another base quantity, and its SI unit is Kelvin. Similarly, electric current is another base quantity, its SI unit being ampere. Okay. Then luminous intensity is there. Its unit is candela. And then there is the mole. You might have studied mole in chemistry. If you are studying chemistry, then you might have come across with the quantity mole. So the SI unit being mole only. So this is all about measurement that we have to discuss during this session. We will move along in our next videos. Thank you for watching this video.